you. Really happy to be here. This is my first time in New Orleans. We're almost wrapping day 2 of this conference. I hope you're enjoying, and thank you for all the organizers and you guys here too. So today I'm going to talk about empowering your Vue apps with AI. This is like a practical guide in the integration of open source and closed models. And before I start, any of you guys follow along what happened this week on OpenAI or Google announcement? If you could raise your hands. Yes? All right, so there's a lot of things going on in AI. But, you know, as JS developers, I figured that we're always having something new. If it's not a new framework, if it's not an update on the Vue library, I'm still catching up with Vue 3. If there's not an update on the browsers that we use. So there's always constant change. And in my opinion, it's really hard to keep up. I mean, have a full-time job and keep up, or either, you know, create content and keep up is hard. And then we see all of these things of AI going on. And I figured, like, what do I need to do? Like, do I need to hop and learn about that? Do I need to add it in my application? Is it hard? As a JavaScript developer, what can I do? And so for today, we're going to build an agent. And what this is going to be is we're not going to do anything that's not JavaScript. We're going to build something, an agent that we won't do any machine learning code, but we're going to stick with our JavaScript code. So I think that's magical. We've heard of some of the speakers of the JavaScript power. So if it's something that interests you, let's get started. So as already mentioned, I'm Eileen. I'm from Mexico. Just a curious person that happens to do code for a living. And yeah, so if you have any coffee recommendations, I would gladly appreciate it. And so to get started, I think we may need to understand what is a model. And maybe you guys were in the talk before. I'm just gonna talk a little about it, just if you weren't there. I envision a model as a black box. And this black box, we're gonna send over, I'm gonna integrate to it by sending an input. And this could be text, audio, or an image. And this box inside has algorithms, has neural networks that would train with huge amounts of data to do something. It's already trained out there for us to connect to. And it's gonna output something. And that output could be an inference, a probability, a text, an audio, or a video, depending on what it was trained to do, right? That's basically how we're gonna integrate with models. And of course, you have heard of the large language models. And why are these so incredible models? AI has been around for a while, but this is the one that makes the breakthrough, because these models are machine learning models that are really good, are understanding and generating human language. I mean, not even animals can do that, right? So that's why it's the huge breakout of AI that we're seeing today. It's based on a transformer architecture done by Google. If you are interested in reading about the paper, it's called Attention is All You Need. And basically, that's how all of these updates came in. They're trained with huge, large amounts of data. That's why they're called large. And in order to generate and understand, that's why they need a lot of data. And they do many tasks. That means that one large language model can do summarization, translation, analyze the text. So they can do a lot of things. And that's why they're super cool. And I want to start off with talking about the closed models and how we can integrate to them. That's how we're going to build our agent today. But what is a closed model? These models, the only way to access them is via the cloud. You'll need to have an account. They'll provide you with an API. Of course, they have a cost. And you cannot download it. You can only access them via API. The closed models, and the most famous ones are ChatGPT-4, Gemini, Claude 3, and Mistral has these small, medium, and large models, I believe. And so for today, I think what could be a cool model or agent that we could build? And I built an agent based on that webpage of the VueConf. So if you have any questions of this agent will help us. So first thing, we're going to do this on steps. And step number 1 is going to be data. So models are amazing, but I need to extend the model because maybe the model don't know something about my business. If it's from an e-commerce, there's data that's not available, and we don't know how these models are trained. So we need to extend that knowledge. And that's where we're going to add our data. So in this case, what I basically did is just scrap the web page, do a TXT file, and that code that you see is basically just a TXT of the scrap of the web page. But maybe in your case, you might need a PDF. Maybe you have a manual for your employees or something. It could be anything. So in this case, I'm just using a TXT, but it could be a database, a CSV, or a PDF. That's step 1. This is basically how I'm reading my TXT file. I'm just reading it, and I'm putting in the VueConf value. Step number 2. I need to split the data. Remember, I had this big chunk of text. I need to split it. Why would I need to split it? First off, to give retrieval performance. Because if I ask you, hey, do you know if there's going to be a Knox talk in VueConf? And you tell, yes, here's the web page. I'll need to go and look for it. So it would be faster if you just give me the information. That's why we want to split the text. So when the agent looks for it, it just got the important information. For this, we're going to use LangChain. And LangChain is an amazing framework that is very useful for LLMs, but it has a lot of functionalities for translation, question answering. But for today, we're just going to use one function, which is basically the one that we're going to use to split the big text. And I'm going to tell it to chunk it for 400 characters. So it's going to go 400 characters with an overlap of 20 and just put it in a big array for me to just see the separation. When I do this, it's going to look something like this. It's going to be an array. It's going to be split in 400 characters. Okay? So step 1 data. Step 2, we split with chunks. All right. So step number 3. And this is a very important concept. I'm not sure if you have heard before, embeddings. So we understand text because we have the knowledge of it, but how does a computer translate and give context to words? And this is when it comes to something called embedding, and it's a process where these chunks that I made, I'm going to use a model to put them, and the model will figure out and put it. This is an example I got from Supabase. We're going to talk about Supabase in a minute. So these sentences are being graphed in a 2-dimension. So it's saying, okay, the cat chases a mouse, the kitten hunts residents. So it's kind of putting it in clusters, like this sounds similar. And this one, like, I like ham sandwiches. Okay, not relevant. I put it in this coordinate. We're saying it very simple in a 2-dimension, but the model that we're going to use today, which is the OpenAI embedded model, has 1,024 dimensions. So it's basically, it's going to find the context and put it and cluster it so it would find similarity in context. This is basically the code that we're going to use. I'm going to call the embedding. I have my OpenAI key, and I'm going to tell him to use a text embedding ARA. I'm going to put the input. So for each input, I'm going to have an embedding, and that embedding is going to be vectors. Vectors, we're going to see how they look. And for each of them, I'm going to say, please put the content. I'm going to make this object of content, which is the chunk, and the embedding, which is the translation to vectors. And then I'm just put it in the data. And this is how it would look. So I would have this big array with the content, which is the chunk, and the embedding, the representation of all vectors. If you see, it's doing 1536, so it's a lot of dimensions. This is the vector of just the first translation, and it's going to do that for all the chunks. So we need to do this. Now that I have the vector and I have it split it, what's next? I need to store it. So maybe you have used any SQL databases or any other type of databases. there's a special database for these vectors, which is called a vector database. I'm going to use Supabase. Supabase is an open source database architecture, and it has the option for you to have your table there and use vectors. Why do I need to store this? Because the agent needs to go fast and look for it. That's why vectors are very useful for these use cases, because it can do similarity searches. So I'm going to create this table. I hope you can see it has an ID. It has the content that I chunked and the vectors. That is the only thing that I need for this case in my database. So vector databases are amazing for similarity search, which is the one that the agent is going to need. And it's good for handling unstructured and semi-structured data. So up until now, we have our data. We split it, we transform it, and we store it. This phase might just happen once, because maybe your data might not change, but if it changed, you might need to do this again. But this is just once, right? But in order for our agent to work, it needs to have the functionality of retrieving and giving an answer. And this is something called RAG. I'm not sure if you have heard of this term, RAG. This is Retrieval Augmented Generation. And this is basically what it's going to do. The user of the agent is going to have a question. But in order to make the similarity search, I need to transform it to an embedding. So I get the question from the user, I change it into a vector by embedding, and then I'm going to find what is similar in my database. And then we're going to retrieve those chunks, and it's going to tell me, okay, I find these ones are similar. So let's go step by step. I have the user's input, and again, I pass it to the OpenAI embedded model. In this case, it's just a 0 because it's just the one input that I'm doing. Then we're going to go to Supabase and look for it, but I'm telling to Supabase, hey, please find this embedding. The embedding is the one that I'm passing in, the vector, and bring me the ones that are over 50% similar, and bring me the 8 that have the 50% probability. It might be less, it might be more, and this is just a number that works for me. This would be try and error. Try to see what works for you, depending on your data, depending how you structure, and also depending on the embedded model you use. So these ones were the ones that worked for me. So what I'm going to get back is all the content in a big array, in a big string, and now I have the context. I went back and brought the context. Now, here is where we're going to use these big large language models. Remember we mentioned what they were good at? They were good at generating human language. So I cannot just give the user whatever I brought back from the database. I need to structure it to give a human answer. And here is where we're going to use our models. Up until this part, not just plugging in OpenAI or whatever model. It's just to generate the answer. And so in this case, I'm using Gemini. You can use whatever models you want. I'm just letting you know that you can use whatever model. It's been said that it's not a good practice to mix models for embeddings and for generation, but you can do it. I'm doing it. And so Gemini has this chat history that can later work because we're going to do a very basic agent, but with a more use case. A common use case would be like maybe the user have a follow-up. So that's why we have the chat history that would later on work for you to build more context if there are more questions from the user. And so I'm going to start the chat with the chat history, and then I'm going to send the message, which is the query. The query, in here, I don't have to embed the question because these models understand the question. So if you see, I'm passing in the context and the query, and in my last part of the result, I have my query, but I already gave that model my context. Okay? So we did step 5. You ready to test it? Okay, let's see if it works. So, this is my agent, and I'm just gonna, just to let you know that this is the actual one. So let's ask a question. When is VueConf? So it says May 15 to 17. That's accurate, right? Okay, let's try another question, a harder one. Let's see. Who is giving a talk about forms? Yes. Is that good? Yes, it's accurate? I don't know. Yes. So, and just to let you know that this is the actual code, let's see the matches. So I can show you how this looks, right? Let's ask another one. Who's giving a talk about components? Let's see. Maria, right? That's accurate? I hope so. And this is how I'm seeing the content coming back. So this is happening. This is the agent that we just built right now. And we didn't touch any other language rather than JavaScript. And that's how you can build an agent, just a base one. You could use LangChain to do more complex things, but I guess with this one, you can build simple stuff. All right, we're not done yet. Let's continue. Yes. So we did all of this just now. But we talk about closed models. What about open source models? We cannot talk about open source without talking about Hugging Face. And Hugging Face is being told to be the GitHub of AI. And this is because it has data sets for you to use, code that you can run with the models that are out there, and models that are open. What does it mean to be open? So, as I mentioned, the Gemini and ChatGPT are not open. You cannot download, you cannot use the code. You don't know how it was trained. But these models that are open, you can download them, you can run them, you can check how it works, you can check the weights. It's open, right? I think it's important to know that Vue is an open source framework. And it's important to also have AI open so we can see it and understand if that's what we need. If not, we could just close models. So there's different kinds of models. There's computer vision, there's natural, we saw already LLMs, but there's different kinds. We saw in our previous talk about TensorFlow.js, if you saw it. So there are different types of model, but how do I do them? For example, LLMs, how do I run them? How do I in open source? You can download them and use your own resources, or you could serve it on the cloud, or you could use Ollama in this case. So it has an SDK for Node. So what it would do is you could connect locally to your computer and then just use it the same way. But still, we're still using an API. What if I tell you that you could run them in the browser? What if I tell you that it's available there? We would talk about not paying about it because we don't have to serve it. We're giving it to the client. We're also talking about privacy. We're also talking that we're expanding the possibilities of this. If there's not enough internet somewhere, maybe it's a solution that is for agriculture, but the model is going to be there available. And I'm going to show you how. This is possible. This is a movement called Web AI. And actually, I recommended this week, there was an update from Google that they are building a Gemma Nano model so you can have it in your browser as an extension. So imagine the possibilities that this open to translate that time. You don't have to go anywhere. It's available for you, an API in the browser for you. So I really highly recommend. This is something that happened this Wednesday. But this is also possible because Hugging Face has a library called Transformers that has Python models. And Zenova, its main contributor, translate most of these models to JavaScript. So we have them available. We heard about TensorFlow.js. Those models are available. And this is possible nowadays because all the things that we have in the browser, like WebAssembly, WebGL, and Web GPU. So I'm going to show you how to do it with Hugging Face, a really cool open source thing. Can you guys see? Does it look better? So what I'm going to do is, it's an npm package. I'm going to install Zenova transformers, and I'm going to import the emp and pipeline. The emp is very important because I'm going to tell it to please use the browser cache. And then I'm going to tell it here to use that model, which is the sentiment analysis, and put it in a pipe, and then I'm going to send an input. So sentiment analysis is a model for natural language processes that would categorize a word or a sentence to positive or negative. So let me do that real quick. So it's just very common. It's not a big deal. So I'm just going to make something here. This is an amazing conference. Positive. But now, let's remove the Wi-Fi. And just to prove that I'm not on Wi-Fi, I don't have internet. I feel tired. Negative. I don't have internet. The browser is there available for me to do this. And this is something that's growing. I really encourage you to follow the Google updates, Zenova. There's also something called, LLM. So this is going to happen. We're going to have those large language models available, and no internet's going to be needed. Well, on the first load, it needs to load, right? But later on, it would be there, available. And so I just want to also mention something that I believe. Let me put back the internet, because I need to show you one last thing. Not every app needs AI. So this is a great tool. It's amazing that we have these tools and we can build amazing things, but we need to also focus on the solutions. What is the problem? What is the solution? Maybe there's always something out there. I don't need to build something with AI. And this is something that happened to Chevrolet. They said, yes, we have chat, GPT. But it wasn't useful. It was just plugging ChatGPT and you could ask whatever. So it was easier for me because I wouldn't need to pay ChatGPT for an inference. I could just go to the chat of Chevrolet and ask whatever. So it's important to build upon things that we actually want to solve. And with that, I just thank you. Hope you enjoyed this talk.